So guys, this is a very important problem. And in this problem, we have a combined, in fact, example of projectile motion with impact, all right? So as you can see, the girl throws the 0.5 kilograms ball toward the wall with an initial velocity of VA is equal to 10 meters per second. Determine A, the velocity at which it strikes the wall at B, and B, the velocity at which it rebounds from the wall. If I know the coefficient of restitution, E is equal to 0.5, and C, the distance S from the wall to where it strikes the ground, right? Because I have multiple parts here, and I can even have another fourth part about the collision between the ball and the floor, right? But they are all based on the same concept. I have here a projectile motion combined with an oblique impact. And why is it oblique? Because in fact, if you take a look here at B, this B will have a certain velocity. So at this point B here, I'm going to have a certain velocity that is oblique, right? V0x will stay the same because this is a projectile motion. So V0x will be always 10 cosine 30 before collision. This is V0x, but Vy is not given. Vby is not given, and I should find it using the equations of projectile. All right? And then whenever I know the components of B, of the velocity of B just before collision, and I know that this is an oblique impact because in fact this is the plane of contact, which means this is the line of impact. However, B is coming with an oblique velocity, which means this is an oblique impact because B has a velocity that is not collinear with the line of impact here, which is x, in fact. So whenever I know the velocity of B just before collision, I can find the velocity of B just after collision, and it will be the velocity that B is rebounding from the wall. Whenever I know the velocity of B, that is the velocity of the ball rebounding from the wall, I can also apply the motion of projectile between B and C to find also what are the coordinates of C. So I have AB, a projectile motion, and then I have at B an impact, an oblique impact, and then I have BC, another projectile motion. Now guys, you can ask me, why should I apply the equations of projectile if I can apply the conservation of mechanical energy? If you have all the inputs and you want to apply the conservation of mechanical energy as we did before in the central impact, of course you can. But after applying the conservation of mechanical energy, guys, try to find the components of this velocity in x and y. Why? Because in fact, the equations of oblique impacts, if you go back to the slides for the equation of oblique impact, you can see, guys, that they are in terms of the components of B, which means I have to apply the conservation of momentum of both particles along the line of impact, which means here in our case along x, I need Vx. I have to apply the coefficient of restitution always along the line of impact, which means I need Vx. I have to apply the conservation of momentum of one particle perpendicular to the line of impact, which means I need Vy. And that's why, guys, I'm saying that you have, even if you apply the conservation of mechanical energy, now here you can't because you need some inputs, but if you can apply the conservation of mechanical energy as we did in the central impact, you can apply it. But don't forget, guys, that the conservation of mechanical energy is related to the total magnitude of velocity. It's half mva squared. Va is the total velocity, while if you want to apply the equations for oblique impact, you have to take the components of these velocities. All right, guys? Everything is clear? Now, if you want to find the equations of the components of these velocities, this means that you have to go back to the projectile motion, because remember, in the projectile motion, we have x and y equations, all right? Now, The common mistake, guys, I think I gave this example as a quiz for some students, some university. The common mistake that I found is that the students consider that this delta y here is nothing but 3, this one, 3 tangent 30. Is this correct? It's not. Why? Because in fact, guys, this is not a straight line, all right? So this is not a straight line. This is a projectile motion, right? Which means this is not a straight line. This is a curved line, okay? It seems like a straight line, but it's not, all right? So make sure, guys, you understand the figure, all right? This is a projectile motion between A and B, which means this is a curved path. Okay, guys, so I cannot say that this is a straight line and apply tangent rule. Tangent of 30 is delta y over 3 meters. So this is not correct, and I have to find this y later on. Not now. Right? So don't be confused. Okay, so the first step here. The first step is to apply the equations of projectile between what and what? Between A and B, right? Of course, in the horizontal, yes, but in the horizontal and vertical directions, right? What are my inputs? I have to first take the reference. So I'm going to take this A as my reference. Of course, you can change it. It's up to you. Let's take this as my reference. I know that XB is equal to what? To 3. It's given. And I know that this is 3. This XB from the equations of projectile in X direction, it's equal to V0x t plus x0. Now, since I took my reference at A, then x0 is equal to 0. V0x is given. It's 10 cosine 30. XB is 3. Then t will be equal to 3 over 10 cosine 30. Right? So since I know t, I have the value in fact, just 1 minute. Yes. So since I know t is equal to 0.34 seconds, then I can find now Vy of B just before collision, because in fact Vx of B just before collision is constant. It's 10 cosine 30. It's always constant for the motion of projectile. So now I can find Vy of B. So what is Vy of B? It's minus 9.81 t plus Vy of B is minus 0.2 plus V0y, and V0y is 10 sine 30. Alright? Which means Vy of B will be equal to 1.602. Now guys, from here I can find the magnitude of velocity because I know Vx of B just before collision, it's the same as V0x, right? Because this is the motion of projectile. It's always 10 cosine 30. So 10 cosine 30 squared plus 1.602 squared, and then SQRT of the answer will give me that VB just before collision, and I'm going to call it VB1, is equal to 8.8. But I'm not going to use the total magnitude because in oblique impact, this magnitude here is useless. You have to use the components, all right? Okay. Now, guys, on the other hand, and without asking me why, I'm going to find YB now, right? I know that YB now is useless, all right? But I need this YB later on. So let's find it now, and then you're going to see why I should find this YB, all right? So this YB here from this point to this point. Let's call it H. Let's call it H. This H here, which is YB, based on this reference at A, this H here is equal to minus half 9.81 T squared plus V0 Y T, which is 10 sine 30 T, plus 0. So this H here, I don't have the value in fact, but this H is important later on because we're gonna use it in the last part. So I don't have the value, sorry guys. Okay, so whenever you know this H, you can find also the whole height of B from the floor, because this one will be H plus 1.5. Right? So T, guys, is 0.34, right? So you can find H. If anyone can find H, guys, half 9.81 times 0.34 squared plus 10 sine 30 T plus 0. Why plus 0, not 1.5? Because I took my reference here, Hussein. I took my reference at A. All right? So it's 2.308. Then if I add 1.5 to see the height from the floor, so the height of B from the floor will be equal to 3.8088.